Hi everyone, welcome back. Today we're on 8.3 day 4 notes. We're going to be graphing graphs of sine and cosine, but we are going to be having some phase changes, some vertical shifts, and different periods that we're going to be working with. So recall that graphs of sine are going to be written as y equals a sine times bx minus c, and graphs of cosine are y equals a cosine and then bx minus c. Okay, but we are going to want to rewrite these when we see them. So for our sine, we always want to factor out, this is for sine and cosine, we want to factor out the b. So I would rewrite this as being y equals a sine. I factor out my b. So I am left with x minus c over b and then plus d. I would do the same thing for cosine. So y equals a times cosine, then factor out your b. So you're left with x minus c over b plus d. Okay, so our amplitude is always going to be the absolute value of a. So that's how tall or how high our graph is going to go and how low it's going to go. Our period, that is written as 2 pi over b. That's how we can find the period. Our phase shift is going to be c over b. And then our vertical shift is d. Okay, so our vertical shift, if d is positive, then we are going up. We're shifting up. And if d is negative, then we are shifting down. Okay, and then if a is less than 0, then we are going to be reflecting over the x-axis. So in our first example, we are given y is equal to 2 sine pi x. Okay, so let's first identify our key information. So our amplitude is 2. So that's our a. That's the coefficient out front. Our period, we find this by 2 pi over b. Okay, now my b, if we look back up here, the b is always going to be attached to that x. So this is my b right there. So this would be 2 pi over pi. My pi's cancel, so my period is going to be 2. So that means that I will complete one full sine graph or one full rotation when we are in, once we complete 2. Okay, so I think that's enough information for us to go ahead and start graphing. So you can set up your graph however you would like. I typically like to use 8 spots as being my one period. So I am going to, I'll switch colors so we can see a little better. I'm going to count over 8 spots. So 1, 2, 3, 4, 5, 6, 7, 8 would be right here. And that's where I want to complete one full sine graph. Okay, so then half of that would give me 1. In between, I'd be at 0.5 and at 1.5. Okay, now my amplitude is 2, so that means I'm going to be going up to positive 2 and down to negative 2. I don't have any vertical shifts, so we're starting right at the origin at 0. Okay, then I can go ahead and start graphing. So I know for my sine graphs, I start at the origin since there's no change. So if I'm starting at the origin, I'm going to also be ending when I'm at 0, when I'm at the x-axis. Okay, and then also right in the middle, I would also be hitting the x-axis. Okay, now a typical sine graph, since there's no reflection here, I reach my maximum first, I go back to the middle, and then I reach my minimum. So if we connect all of this, our graph is going to look like something like this. And then it keeps going. Okay, so if you're asked to identify a little bit more information on an assessment, you might be asked what are the x-intercepts. So the x-intercepts would be 0, 0, 1, 0, and then 2, 0. Okay, you might be asked where is the sine graph increasing. Could also be asked where it's decreasing. So the increasing intervals would be from 0 to 0.5. And then also from 1.5 to 2. Okay, so that's where I would be increasing. I'm increasing here, if you can see that highlighted in a light blue, and I am again increasing right there. Everywhere else I'd be decreasing. Okay, number 2, we are given the same equation except it is negative. So y is equal to negative 2 sine of pi x. Okay, so once again, my amplitude is going to be 2. Remember, it's the absolute value. The period, well, I find this the same way, 2 pi over b, and we know that the b is pi. So again, my period is 2. So once again, I'm going to count out 8 spots. 1, 2, 3, 4, 5, 6. So right here would be my 2, my 1, 1.5, and 0.5. Again, there's no vertical shift, so I'm going to be using positive 2 and negative 2. Okay, now the difference with this graph is that we have that negative out front. So that means I am going to be reflecting over the x-axis. So my x-intercepts will remain the same. The only thing that is changing is my maximum and minimum. Since we are reflecting, I'm going to be going down first. So at 0.5, I'd be at negative 2, and at 1.5, I'd be at positive 2. Okay, so let's identify our x-intercepts again. Those have not changed, so we are at 0, 0, 1, 0, and 2, 0. And then if we want to know our intervals that are increasing again, that would be only from a half, so 0.5 to 1.5. That's where I am increasing. Everywhere else, I'd be decreasing. Okay, number 3, we have y equals negative 2 minus 2 cosine times 3 pi x. So the first thing I would do for this is rewrite this so that my vertical shift comes at the end, like how our parent graph is written. So y equals negative 2 cosine 3 pi x and then minus 2. I think that looks a little bit clearer for us to see that we have a vertical shift of negative 2. Okay, so let's identify our key points. So our amplitude is going to be positive 2. My period, that again we find by 2 pi over b. Okay, so 2 pi, and if we notice, our b is going to be 3 pi. So this whole part is going to be my b. So my pi's cancel out, and I am left with 2/3 being the period. Okay, and then this time we do have a vertical shift, and I am shifting down 2. Okay, so I'm going to count out 8 spots, and that's where I'm going to put my 2/3. Okay, so halfway back, that would give me 1/3. And then I'm just going to put little tick marks in between. Okay, now my amplitude, that is 2. However, we have a vertical shift of negative 2. So that if I go down 2, I'm really going to be starting, or my maximum would be at 0, and my minimum would be at negative 4. So negative 2 is actually going to be the middle of our graph here. Let's make that a little more clear. All right. So I also know that since we have this negative 2, I'm going to be reflecting over the x-axis. So my first point for cosine is usually at my maximum. However, since we're reflecting, it's going to be at the minimum. So my first point is going to be at 0, negative 4. So I also know for a cosine graph, we start and end at our maximum, in this case, the minimum. So I'm going to end this period at 2/3. Okay. Then I usually reach my minimum. So in this case, since it's reflected, it's our maximum right in the middle. And I know my maximum is going to be at 0. So then in between, I'm going to be right in the middle at where normally 0 would be. And since we are moving down 2, we are at -2. Okay, so if I connect my points, our graph will look like this. Then it'd be continuing up if I continued this for an additional period. Okay, so my x-intercept, here we are at 1/3 0. And then if we want to identify our intervals where we are increasing, well, we are increasing from 0 to 1/3. Okay, number 4, we have y equals cosine times 2x minus pi. So here we notice that since there's some addition or subtraction on the inside of the parentheses, I have a phase change or a phase shift. So I want to factor out that 2. So I'm going to rewrite this as being y equals cosine 2x minus pi over 2. So my amplitude is just 1. The period, that's 2 pi over b. So 2 pi over my b is 2. So my period is just going to be pi. Okay, then my phase shift, that's pi over 2. So since it's negative pi over 2, that means I'm going to the right. So right pi over 2. And I do not have any vertical changes, so I'm not going up or down. Okay, so this is cosine, and my period is pi. So I'm going to count over 8 spots. And that's where I'm going to put my pi. So halfway in between would be pi over 2. I'd also have pi over 4 and 3 pi over 4. My amplitude is just 1, so I'm going to be going from +1 to -1. Okay, so you might like to do this a different way. The way I like to do these is where I am going to graph this without a phase shift, and then once I know what the parent graph will be, then I complete my phase shift. So if you like to do it a different way, go ahead and try your way. If you want to follow along, that is great as well. So cosine, I start at my maximum. There's no reflection, so I'm going to stay at my maximum. So that would be at 1. And I know I'm also going to end at 1. I know that my minimum is right in the middle, so that would be at pi over 2. And then in each of those middle spots is where I'm at the middle. Okay, so I want to be shifting. So I'm going to do this in red now. I am shifting right pi over 2. So I'm actually going to add a few more tick marks. So if I go one more over, I'd be at 5 pi over 4 because I'm just increasing by pi over 4. And then one more time, I'd be at 3 pi over 2. Okay, so if I want to move pi over 2, I'm just going to start at my beginning. So at 0, 1, I'd be moving to be at pi over 2, 1. Okay, this blue one right here is going to be shifting over there. My minimum is going to shift over to pi back here, and then at 3 pi over 2, I'm at my maximum again. So my final graph is what's in red. And that's what it looks like. Okay, now you might want to check with your teacher if they want you to erase the other marks. If you are in my class, you are welcome to leave it there. Just make sure on like an assessment, I know what your final graph is. So if you want to mark, if you use different colors, and if you want to say red equals final, that would be fine with me. Somehow just make sure that we know what your final graph is. Okay, number 5, we have y equals 4 cosine times 3x minus pi over 4. So once again, I have a phase shift, so I'm going to rewrite this. So y equals 4 cosine, factor out the 3, I'm left with x minus pi over 12. Okay, so my amplitude is 4. The period, that's 2 pi over b, and b is 3. And then my vertical shift, sorry guys, that should be phase shift, not vertical shift. That's negative pi over 12, so that would be moving right pi over 12, and I don't have a vertical shift here. Okay, so starting out, let's count 8 spots over. So that is 1 period, so that would be where 2 pi over 3 goes. Right in the middle, I've got pi over 3. And then let's include some more points since we're going to end up having a phase shift pi over 12. Let's get some more points in there. So I will have pi over 6. I will have pi over 2. Then if I keep going, I know that each one of these tick marks is actually going to be pi over 12. So if I know that, then I know how far I'm going to end up having to do my phase shift. Okay, so if I wanted to add a few more, pi over 4 would be right here. Okay. My amplitude is 4, so I'm going from positive 4 to negative 4. And then once again, I am going to first sketch the graph, and then I will go ahead and do my phase shift. So I'm going to first sketch it without a phase shift. So cosine, I start at my maximum, and then at the end of 1 period, we're also at our maximum. Right in the middle, which is pi over 3, is where I reach the minimum. And then in between each of those points, so at pi over 6 and pi over 2, I would be right at 0, right in the middle. Okay, so again, I'm going to use red now to sketch my final graph, and I am just moving pi over 12. So every mark or every point is just going to be shifting over 1 tick mark here. And that would be my final graph. Okay, so our last one, number 6, is y equals 1 minus cosine times 2x minus pi over 3. So there's a lot of different changes going on here. Our first step is going to be to rewrite this. So let's rewrite this as y equals negative cosine. I'm going to factor out the 2. So 2, and then x minus pi over 6. And then my vertical shift of up 1 I'm going to include at the end. Okay, so my amplitude is going to be 1. My period, I find that by 2 pi over b. So I would have 2 pi over 2, which just equals pi. Then my phase shift, that's going to be pi over 6. So I'm going to be moving right pi over 6 since it's negative. And then my vertical shift, that's going up 1. Okay, so usually we go over 8 spots. Since my phase shift is going to be pi over 6, I want to either count out 6 spots or 12 spots just so it's an easier phase shift. So I'm going to pick 12. It's up to you what you want to pick. As long as you label your graph, it doesn't matter. Okay, so I'm going to count out 12 spots. Okay, so each spot would be pi over 12. You don't necessarily need to label every single one. Just make sure you label enough, at least with some key points in there. Okay, and so since there are so many different changes, the order that I'm going to do this in is first I will graph the phase shift, then I will go ahead and do the reflection, and then last I'm going to do the vertical shift. Okay, but my very first sketch is just going to be the original cosine graph. So my amplitude is 1, so I'm just going from +1 to -1. Okay, I'll use green for the first one. So for cosine, we typically start at our maximum, and that's where I would also be ending at. My minimum would be right there in the middle, and then I reach the x-axis in between each of those. Okay, so now let's go ahead and do our phase shift. So I'm gonna have lots of different colors going on here. And I'm also, since I'm going right, I'm gonna include 2 more tick marks there. So I am going right pi/6. So each one of these points, I'm just going to move over 2 tick marks, since that would be pi/6. Okay, so that covered my phase shift. Next, I'm going to reflect it. Oops, sorry, I'm not using green. I'm only reflecting the ones that are blue. Okay, so now I have my reflection done. And the last thing I'm going to do is my vertical shift. So I'm moving up 1. So each purple, I'm just going to be moving up 1 spot. I said purple and then I did my green. So this would end up being my final graph. Right there.